Hey, welcome everybody. Welcome to another episode of What's Up with the Universe. I'm your host, Eli Hugh, and I just want to remind everybody, thank you for joining here. I want to remind everybody to don't forget to click that like button. Don't forget to subscribe and ring that bell so you know when I go live. Yep. I just want to welcome everybody here to a special show today. But before I begin and can't talk anymore or properly again as usual, I want to remind everybody that I'm a member of the Khaos crew, and every Tuesday night there is a Khaos Central. So check it out, people.
All right, the Khaos list. Tuesday nights, 9 p.m. Eastern Standard Time. The Khaos list. Do not miss this. Do not miss this. Peace.
Yeah, every Tuesday night, 9 p.m. Eastern, we talk pop culture, nerd stuff, even controversial shit. Yes, we talk everything. But on this show right here today, we're talking about the universe. Yes, today, the top 10 wonders of our solar system. So, let us begin.
Top 10 countdown.
Number 10. Who discovered the rings of Saturn? Huh. Well, Saturn has been known since prehistoric times because it's easily visible with a naked eye. I mean, not until the invention of the telescope did people actually started to look at Saturn's rings and stuff. I mean, the first person who actually looked at it was Galileo Galilei. He was the first to observe Saturn with the telescope in 1610. I mean, because the way his telescope was, he couldn't really determine what the rings were. I mean, he incorrectly guessed them that they were two large moons. Hey, Corin, again?
Hey, what's happening? This is Corin Nemic. I'm talking to you from my backyard. I just signed up for Cameo app for Sean Ass and told me that's what all the cool kids are doing. So I'm just trying to be one of the cool kids. But I am dedicated to this. Dedicated to leaving you a message, no matter what the conditions are. That's why I'm doing this in the rain, to prove to you how serious I am about this. I mean, I will give you a shout out from a train. I'll give a shout out to you while I'm on a plane. I'll give a shout out to you from a car. I'll give a shout out to you from a dive bar. In fact, I heard that David Faustino's on here as well. He said that he was going to give some weird and creepy shout outs, but I challenge him. You want a weird and creepy shout out? Came to the right place, buddy.
Get out of here, man. Come on, dude. I'm trying to talk about Saturn's rings. Jeez, look, just book a cameo with Corin Nemic, okay? I'll put the description down after the show, man. You keep saying interrupting. We were talking about Galileo Galilei. He was the first to observe Saturn with a telescope in 1610. I mean, because of the way his telescope actually was, he really couldn't see what they actually were, and he incorrectly guessed large two moons on the inside of Saturn. He thought they were actually moons. I'm like, hey, does this planet have ears? I mean, we know this because Galileo was viewing the rings edge on, so they were invisible. But at the time, it was kind of confusing to him. Excuse me. I mean, after another 2 years, he viewed Saturn again and found that the moons had returned. He included that the rings were arms of some sort or maybe ears. He really didn't know. We didn't actually find out until 1659 when Christian Huygens, he's a famous Dutch astronomer, he recognized them as actual rings himself. I mean, Saturn's rings, they make up an enormous complex structure. From edge to edge, the ring system would not even fit in the distance between Earth and the moon. There are 7 main rings that are labeled in order from which they were discovered. From planet outward, they are the D ring, the C ring, the B ring, A ring, F ring, and G ring. I mean, the G ring is very faint and it's closest to Saturn. The main rings are A, B, and C. The outermost ring is easily seen with Earth-based telescopes, just like the A ring is. The Cassini division is the largest gap in the rings and separates the B ring from the A ring itself. I mean, just outside the A ring is the small, thin little F ring. It's separated by two little small moons, Pandora and Prometheus, not the computer program that LDG wants to install. No, it's actually a moon of Saturn, LDG. It's called Prometheus. Beyond that, there are two much fainter rings named G and E. Of course, I mentioned LDG's probably didn't show up. The E ring, Saturn's E ring, is the largest planetary ring in our solar system. It extends from Mimas' orbit to Titan's orbit, which is about 621,000 miles, or 1 million kilometers, for everybody who is not that really keen on the metric system, or uses the metric system. So, I mean, the particle in Saturn's rings are composed primarily of water and ice, and range in size from little teeny grains of rice to tens of meters tall, sometimes even mountains. These rings show structure on all types of scales. I mean, they also interact gravitationally with many of Saturn's moons. One moon in particular, Pan, actually orbits inside the A ring. It's about a 200 mile wide gap between the Encke gap. The main rings, A, B, and C, are less than 100 meters thick in most places, 300 feet. They basically compare to the rotational extent of about 38,000 miles. The main rings, they're much younger than the age of the solar system, perhaps only a few 100 million years old. I mean, they may have formed from breakup one of Saturn's moons, from a comet or a meteor that was torn apart by Saturn's gravity. Still, we do not know where they came from. Number 9. Wonder of our solar system is the Great Red Spot. Yes, the Great Red Spot. I mean, when you think of Jupiter, you may think of its massive size, the bands of gas all around the surface of the thing, or you just may think of the iconic large storm, excuse me, which is basically a giant red hurricane twice the size of Earth. I said twice because it's shrinking. I mean, this is called the Jupiter's Great Red Spot, the GRS. It's captivated humans for hundreds of years, basically. It was first observed in 1831 by amateur astronomer Samuel Herschel Schwabe. I'm going to go full screen so you guys can actually see these images. These are actual Hubble images on these things that I took from NASA. So enjoy a little Jupiter's red spot here, because it was observed in 1831 by Samuel Schwabe, and he did not get these clear pictures. We know that the storm has existed for at least 150 years. But of course, it could be older than that, because some astronomers speculate that Cassini, he wrote a poem called The Permanent Storm. And back in 1665, they think that he's referring to it as the Great Red Spot. I mean, it's basically, it spans Jupiter. It doesn't have a solid surface. Jupiter, it's gaseous. Jupiter's quote-unquote sky is 44 miles deep and also consists of cloud layers made up of ammonia ice, ammonia hydrosulfide, a little bit of water ice, and some vapor. I mean, you may ask yourself, hey, what exactly is the Great Red Spot? Well, it is a gigantic storm that is about twice as wide as Earth, circling the planet in its southern hemisphere. At the storm center, these winds are relatively calm, but toward the outer bands of the storm, they can reach up to 425 miles an hour. I mean, that's twice the speed of even the strongest hurricanes on Earth. The storm is contained by an eastward moving atmospheric band to its north and a westward moving band to its south. These swirling bands are also what formed the storm in the first place and basically kept that storm spinning for more than a century. I mean, scientists believe that these layers exist in an ocean of liquid hydrogen, and beneath that ocean is the planet's core. But we're not exactly sure exactly what Jupiter is made of yet. The wind speed, like I said, it can reach up to between 270 to 425 miles an hour. This spot is also called an anti-cyclone. That basically means the winds circulate counterclockwise to that of a cyclone on Earth. Nearly just the size of Earth, the red spot could be terrestrial or hurricane. I mean, the red spot, like I said, the red spot, it's not getting any bigger. It's actually shrinking in size. Yeah, a couple years ago, we thought it was 3 times. Now it's twice the size. Was it in 79? It was 1/3. It was reduced about 1/3 in size. Basically, at this rate, it could transform into the oval shape into a circle by the end of 2040. That's 19 years away, people. I mean, one of the things about the Great Red Spot is it's still not clear why it's red. I mean, the reason why Jupiter has a Great Red Spot, it's assumed that Jupiter is red because of the ammonia filled with clouds, concentration of hydrocarbon, acetylene, beating from high-powered solar radiation. These chemicals involved, they might contain a proportion of sulfur and phosphorus, which can cause that red color. I mean, the way the red spot moves across to Jupiter is one of the lesser-known facts that it remains at the same distance from the equator. It moves east and west across the planet as the storm persistently prevents it from moving north and south. I mean, it locks the anticyclone around 20 degrees below the planet's equator. It basically makes sure it doesn't enter the northern hemisphere. That's why it always remains an anticyclone. It takes about 6 days for Jupiter's red spot to make a full rotation. This is about the size of the Earth right now. If Earth was actually fit in a red spot, that's how much it shrank. You may not know about this, but the red spot is actually hotter than planets. That's what you're thinking, right? Nope. It remains cold. Yep, it's cold. It's cold because air rising within the vortex expands and cools down. And the cooling causes the gas to create a thick cloud over the spot. We did not know why we don't know exactly why it's shrinking, but as you can see below the picture, there's Junior right there, the great white spot. We're still trying to determine the storms on other planets. I mean, it's still considered one of the largest storms in the system, though. The GRS is referred to as the largest storm in the solar system, according to NASA. Astronomers using the Hubble. It's kind of tricky to see from Earth every day. I mean, only if it was having a clear sky, but the Hubble is the best way we've been able to get pictures. This is why I'm having this full screen so you guys can catch all these images from the Hubble. This is beautiful. Sorry, excuse me. Okay. The great red spot. The great red spot. It has actually lapped the Earth 10 times since its discovery. Like I said, it's continuously moving across the planet's atmosphere with a varying speed. It also recorded that the Great Red Spot has lapped the planet at least 10 times since its total discovery. And the roaring storm itself, it sits between 2 high-speed jet streams. The streams where it sits moves in opposite directions, pulling the storm eastward to southward and westward toward the north. I mean, the flow provides momentum for the anticyclone itself. Okay, we are on to number 8. You ready for this one? Number 8 is Olympus Mons. Yes, the largest volcano in our solar system. I mean, we have different volcanoes that are active. We have some on Titan, we have some on Io, we have some on Earth, but Olympus Mons on Mars is the largest volcano. It's in the Tharus Montes region. It's basically a volcanic. It's a shield volcano, about 374 miles in diameter. It's about the size of, get this, Arizona. That's how big it is. Yeah, it's about the size of Arizona. Okay, this is how huge it is, okay? Like I said, it's about 374 miles in diameter. It sits at 25 kilometers high, and is rimmed at 4-mile-high scarp. The caldera is 50 miles wide, is located at the summit of Olympus Mons. I mean, to compare, the largest volcano on Earth is Mauna Lea, and Mauna Lea is a shield volcano, which is 6.5 miles high, 120 kilometers across. The volume of Olympus Mons is about 100 times larger than that of Mauna Lea. Yeah. The whole entire chain will fit inside from Kauai to Hawaii. What if I fit inside Olympus Mons? It is so big. I know. How big is it? It is so big that it rises, that these are 10 to 100 times larger than anywhere else on Earth. It's such a slow grade. You want to be realized that you're climbing up a mountain. It's just a slow start creep. I need a drink because I can't talk anymore. Oh my gosh. One moment. Okay, that's better. Okay. The gradient is so gradual. You wouldn't realize climbing up a mountain because hotspots remain stationary on Mars because there was one huge tectonic plate. Unlike Earth, where there's multiple tectonic plates, and the one in Hawaii is constantly moving itself. That's why you have multiple islands. That's Earth's hotspot itself. I mean, Olympus Mons, like I said, stands 16 miles or around 3 times as tall as Mount Everest, which, like I said, it makes Mount Olympus Mons the largest volcano in the solar system. Whether it's German or not, it's still technically a volcano. Okay, number 7 on our top 10 wonders of our solar system just happens to be what's going to happen coming up pretty soon. A total solar eclipse. Yes, a solar eclipse. Well, not total, but Europe's going to get a partial solar eclipse, and we are going to get a total lunar eclipse. I'll tell you about a solar eclipse. I'll tell you about a solar eclipse. What exactly is an eclipse? Well, an eclipse of the sun occurs when the moon passes between the Earth and the sun. The moon blocks the light of the sun, and the shadow of the moon is cast on the Earth's surface. I mean, when the moon fully or partially obscures the Earth's view of the sun, that is what is called a partial eclipse or total eclipse. During a solar eclipse, the moon actually casts 2 shadows toward Earth. Get this. One shadow is called the umbra, which becomes smaller as it reaches the Earth. The second shadow is called the penumbra, which becomes larger as it reaches the Earth. A total solar eclipse, or a complete blocking out of the sun's light, can only be seen from the area of the Earth's surface that enters the moon's umbra, the smallest shadow. People viewing it from the eclipse from other areas of the Earth's surface enters the penumbra or larger shadow will only see a partial blocking of the sun. A total solar eclipse can only happen when 2 events happen at the same time. The first event is a new moon. The phase of the moon occurs when the sun is almost direct behind the moon, of course. During this time, the moon and the sun appears close together. The second event that must occur is that the moon must be in the right position directly in the line of sight between the Earth and the sun. These 2 events occur at the same time about once every year and a half or so. I mean, in a solar eclipse, the moon moves between the Earth and the sun. Okay, when this happens, part of the sun's light is blocked. The sky slowly gets dark, and the moon moves in front of the sun. When the moon on a perfect line, it's called a total eclipse. These are very, very rare on the surface of the Earth. I mean, most people only see it once in a lifetime or a partial eclipse. I mean, whether objects are close to us, they appear to be bigger than objects that are far away. For example, most stars in the night sky look like they're tiny white dots of light. In reality, many of those stars are larger than our sun. They're just much farther away from Earth. Even though the moon is, get this, 400 times smaller than the sun, it's also about 400 times closer to Earth than the sun is. That means that from Earth, the moon and the sun appear to be roughly the same size in the sky. So when the moon comes between the Earth and the sun during total solar eclipse, the moon appears to completely cover the light from the sun. Of course, it won't always be this way since the moon is moving 1.5 inches away from us every single year. Number 6. Yes, I know, guys. That is sad. Okay, yeah. Number 6. wonder of our own solar system happens to be, get this one, we're going back. Yep, we're going back to Saturn because we're going to be talking about Saturn's hexagon. Yes, if you weren't aware of this, Saturn has a hexagon. I mean, it's similar to Earth's polar vortex, which has winds blowing in a circular pattern around the polar region. On Saturn, the vortex has a hexagon rather than a circular shape. I know, it's pretty cool. The hexagon is nearly about 15,000 miles across, or 25,000 kilometers. They're not Americans. Basically, it's so large that nearly 4 Earths can fit in it. There are 2 scientists who did a model. Their names are Jeremy Bloxham and Rasha K. Yadav. Sorry, I cannot pronounce if I mispronounced your name, sir. They are the Madeline Potiphar Professor of Geophysics and Research Associates. They work in the Bellhams Lab in Harvard Department of Earth and Planetary Sciences. What these guys did is amazing. They created a 3D model simulation of Saturn's atmosphere. I mean, they believed in closing in on an answer. In their paper, these 2 scientists say that when the unnatural-looking hurricane occurs, when atmospheric flows deep within Saturn creates large and small vortexes, kind of like little mini cyclones that surround a larger horizontal jet stream blowing east near the planet's north pole, and also a number of storms within it. These smaller storms interact with the larger system, and as a result, effectively pinch the eastern jet and confine it to the top of the planet. The pinching process warps the stream into a hexagonal shape. As you can see in this little animation here, this is the jet going around and around the planet, and it has to coexist with these localized storms, Yadav said. He said, think of it this way, quote, imagine we have a rubber band and we place a bunch of smaller rubber bands around it, and then we just squeeze the entire thing from the outside. That central ring is going to be compressed by some inches and form some weird shape with a certain number of edges. That's basically the physics of what is happening. We have these smaller storms, and they're basically pinching the larger storms at the polar region, and since they have to coexist, you have to somehow find a space to basically house each system. By doing that, they make up this polygonal shape. I mean, regardless of how many hypotheses exist and how the storm formed, most center on 2 schools of thought. One suggests that the hexagon is shallow and only extends hundreds of kilometers deep. The other suggests that the zonal jets are thousands of kilometers deep. Our next wonder of our solar system happens to be close to home. Yes. Guess what it is? It's Mars. Yes, not just Mars, but water on Mars. I mean, almost like people is like, hey, does the water have Mars? A couple hundred years, people looking at this like, is there water on that planet? Well, let me answer that question for you. Yes, there is. Because almost all water on Mars today exists as ice. Although it exists in small quantities, it's vapor in the atmosphere, it's still water, H2O. I mean, what was thought to be a low volume of water, brines and shallow Martian soil, also called recurrent slope lineage, maybe grains of flowing sand and dust slipping down downhills to make dark streaks. The only place where the water is visible at the surface is at the North Polar ice cap. I mean, abundant water also is present beneath the permanent carbon dioxide ice cap on the Martian South Pole, and also in the shallow subsurfaces at more temperate conditions. Scientists estimate that more than 5 million kilometers of ice have been detected at or near the surface of Mars. It's enough to cover the planet in a whole ocean of 35 meters deep. I mean, even more likely ice to be locked away in the deep subsurface. Observations of the red planet indicate the rivers and oceans may have been prominent features in the early history of Mars, billions of years ago. Scientists speculate that Mars was once a warm and wet world that had supported microbial life forms in some regions. But this planet is smaller than Earth, less gravity, and a very thin atmosphere. Of course, over time, as liquid water evaporated, more and more of it escaped into space, allowing less to fall back to the surface of the planets. People ask, hey, what happened to this water today? Well, liquid water appears to flow from some steep, relatively warm slopes on the Martian surface, known as RSLs, as the recurring slope lineage. They were first identified in 2011 by the HiRISE camera. It's aboard the Mars Reconnaissance Orbiter. Yep. Sorry. These slopes carved in the Horowitz crater on Mars suggest that the red planet might currently host liquid water. I mean, colors have also strongly been enhanced to show these subtle features here. The light orange streaks, black arrows in the upper right, that may mark faded lines here. The dark streaks, which appear seasonally, were confirmed to be signs of salty water running on the surface of the planet. If this is correct, then the RSL on Mars may represent the surface expression of a far more significant ongoing drainage system on the steep slopes in the mid-latitudes. That is what a quote from a researcher at JPL said. And I just knew it. See, I talked about him and he showed up. Of course. Never fails. Okay. Yeah, Mars. The detection of these hydrated salts on these slopes means that water played a vital role in the formation of these streaks. Luhandra O'Hara of the GIT in Atlanta said that in a statement, these vast deposits of water appear to be trapped within the ice caps at north and south poles of the planet. I mean, as Mars orbits each summer, the temperature increases. The caps shrink slightly, and the contents skip straight from the solid to gas form. But in the wintertime, cooler temperatures cause them to grow to latitudes as low as 45 degrees, or halfway to the crater. I mean, the caps on average are about 2 miles thick and is completely melted. Could cover the Martian shore with about 18 feet of water. I mean, frozen water also lies beneath the surface. They discovered large slabs of ice as large as California and Texas, combined in the region between the equator and North Pole of the red planet. For decades, abundant research has suggested that rivers basically have been locked into the Martian subsoil here. Sorry. I need a drink. Should have more water. That's better. Sorry about that. What was I talking about? Oh, yes. I was talking about the research. Research has suggested for about 30 years or so that rivers, lakes, and seas once covered Mars billions of years ago. I mean, example, 2015. Maps of water in the Martian atmosphere suggested that Mars might have once had enough water to cover up to a fifth of the planet. In addition, in a different 2015 study, researchers also noted that the shape of some of the Martian pebbles suggested that they once rolled in dozens of miles down a river, little round balls, hinting that ancient Martian waterways were stable and not merely fleeting streams. I mean, frozen water may just not exist at high latitudes at the Martian poles, but also at mid-latitudes. I mean, like I said, in 2015, scientists discovered a huge giant slab of ice as big as California and Texas combined. It's buried just beneath the surface of Mars between its equator and North Pole, covered in the protective layers of a whole bunch of dust. I mean, Mars, it also has water in the form of hydrated minerals. This is basically minerals that have water chemically bound to them. This is something that maybe future Mars missions could use to extract water by heating hydrated minerals. Who knows? I mean, new findings from the MRO, sorry, acronyms again, the Mars Reconnaissance Orbiter, they have provided the strongest evidence yet that liquid water still flows intermittently on Mars to this present day. I mean, dark narrow streaks recurred, like I said, the sling lines aiming at the walls of the Gearing crater on Mars here. These streaks here are about a few hundred meters in length. Yeah, I know. These are basically hypothesized to be formed by flow of a briny water on Mars. To quote Nature Geoscience, Alejandro Odra said, quote, We found the hydrated salts only when the seasonal features were whitest, which suggested either the dark streaks themselves or a process that forms them is near the surface of the hydration. In either case, the detection of hydrated salts on these slopes means that water plays a vital role in the formation of these streaks. So yes, there is water on Mars, people. And now we are down to our number 4 top wonder of our own little solar system. Still close to home, of course. It happens to be Venus. Not just Venus, but is there life on Venus? Well, it's a subject of astrobiology due to its proximity and similarities to Earth. Life could happen beyond Venus, but there has been actually no definite proof yet of past or present of life on Venus yet. I mean, theories have decreased significantly since the early 60s when we began to study the planet and became clear that the environment was completely hostile and did a 180 to Earth's environment. Of course, however, there's an ongoing study as to whether life could have existed on the Venetian surface before a runaway greenhouse effect took hold. Relatively studied basically whether a realistic biosphere could persist high in the modern Venus atmosphere. Of course, like I said, like I asked, is there life on Venus? Well, astronomers may have found a signature of life. Evidence in cladding indicates phosphine was detected. Let me explain what phosphine is. I'll try my best. It's a gas associated with living organisms and is present in the habitable region of Venus's atmosphere. Scientists at MIT Cardiff University and elsewhere have observed what may be signs of life in the clouds of our outer, even most planetary neighbor, Venus. But there has been no direct evidence found of any living organisms yet. In their observations, they say that some sort of aerial, quote unquote, aerial life form in Venus's clouds. I mean, it's the only habitable portion of what is otherwise a scorched and hospitable world. The astronomer led by Jane Grievous of Cardiff University detected in Venus's atmosphere a spectral fingerprint, or basically a light-based signature of phosphine. I mean, MIT scientists have previously shown that if this gas were ever to detect on a rocky terrestrial planet, it could only be produced by a living organism there. These researchers concluded that made the detection using the James Max Clark telescope and the ALMA in Chile. The MIT followed up using brand new observations with different telescopes and others. I forgot what telescope they used, but they also detected phosphine in Venus's sulfuric environment. One of the best scientists, I would actually quote on this, is CLARA SOUSA-SILVA. She is a research scientist at MIT's Department of Earth, Atmospheric and Planetary Sciences, otherwise known as EAPS. She said, quote, "It is very hard to prevent a negative. Now astronomers think of all the ways to justify phosphine without life, and I welcome that. Please do, because we are at the end of our possibilities to show antibiotic processes that can make phosphine. This means either that this is life, or it is some sort of physical or chemical process that we do not expect to happen on rocky planets." The MIT also, led by Brains and Pradowski, used computer models to explore all the types of possible chemical and physical pathways not associated with life that could produce phosphine in Venus's environment. Brains considered various scenarios that could produce phosphine, such as sunlight, surface minerals, volcanic activity, meteor strike, and even lightning. But in every scenario they considered, the phosphine produced would only amount to a tiny fraction of what new observations suggested that is present on Venus's clouds that could possibly be life. And SOUSA-SILVA went on to say, quote, "Technically, biomolecules have been found in Venus's atmosphere before, but these molecules are also associated with 1,000 things other than life. The reason phosphine is special is, without life, it is very difficult to make phosphine on rocky planets. Earth has been the only terrestrial planet where we have found phosphine because there's life here. Until now, unquote. And I would link her page down at the end of this page because for the past 10 years or so, she has been studying phosphine. This is her specialty. And number 2, on our wonder of her own solar system. Sorry, number 3, I lost count. On our wonder of our own solar system. We are talking about the brightest object in our solar system besides the sun, the most reflective object, Enceledus. Yes. I mean, it was discovered on August 28th, 1789. Enceledus is wide as Arizona. It orbits Saturn at a distance of about 148,000 miles. It is tidally locked with Saturn, keeping the same face toward the planet. And it completes about 32.9 hours to complete one orbit within Saturn's E-ring. I mean, Enceladus is the cause of Saturn's E-rings because of these jets right here. These jets are shooting out hundreds of meters, about 400 meters per second. There's scientists are saying that the amount that the geysers of these tiger straps are shooting out is enough to fill an Olympic swimming pool in a few hours. This is how much this water is. Free samples everywhere. Look at this. I mean, this is NASA's Cassini spacecraft. Get this. They captured this image on November 30th, 2010. The shadow of the body in Enceladus and the lower portion of the jets is clearly visible. I mean, okay. It has an icy crust, then a global ocean, and then a rocky core. Scientists basically predict that the regional reservoir is about 6 miles deep and lies under a shell of ice about 20 to 25 miles deep. It's basically at the South Pole. The underground ocean is thought to feed the moon's impressive jets. These are called, from figures called tiger stripes. Several of these gases include water vapor, carbon dioxide, methane, possible ammonia, either carbon monoxide or nitrous gas make up these plumes. I mean, the density of organic materials on the plume was about to be 20 times denser than scientists actually expected. Free samples. All we got to do is get a little probe out there and go, hey, we did it to a comet. Why can't we do this to Enceladus? Come on, please. Free samples. Okay, enough about the shiny object. But now, number 2 on our top wonder of our solar system. Where will we go here? Well, surprise, surprise. Number 2 happens to be something you never think I would talk about. Really? Yep, because number 2 is Pluto. Yes, Pluto. Unbeknownst to us, we did not know about Pluto until February of 1930 when Clyde Tombaugh, he would photograph the same part of the sky over and over and over and over again. He used a Zeiss blink comparator. It used to detect the motion of nearby planets against the more distant fixed stars. He found a distant planet on platelets taken on the 23rd and 29th of January. And it was the official discovery was announced on March 13th, 1930, which just happened to be his birthday. I know, what a great birthday present. I mean, Pluto, okay, it's a minor dwarf planet. It's in the Kuiper Belt, a ring of bodies basically orbiting past Neptune. It's about 715 miles, with a radius of 715 miles, and about 1/6 the width of Earth. If Earth was the size of a nickel, the Pluto would be the size of about a piece of popcorn. I mean, it has multiple craters on the side. It has fractures. It has the Tombaugh region, which is the strangulated mountains, which reach about 11,000 feet high. And of course, you can see the prominent heart. I mean, from an average distance of about 3.7 billion miles, Pluto is 39 astronomical units away from the sun. From this distance, it takes light about 5.5 hours to travel from the sun to Pluto. The interior, this is what the New Horizons detected when it flew by Pluto. It has a frozen nitrogen on the outer side with a water ice in the middle And it has a rocky core. Yes, Pluto has ice. Yes. See, Enceledus is not the only place with water. I mean, if you were to stand on the surface of Pluto at noon, the sun would be, get this, 1/900th the brightness as it is here on Earth. It's basically lighting a match in a enclosed football stadium, and the match is about 100 yards away. That's how bright it is. There is a moment each day near the sun where here on Earth where the light is the same as brightness as the midday on Pluto, though. Of course, our exploration of Pluto has varied range from our observations. In 1994, we actually took a very first image of Pluto. This is what we thought it looked like. All gray and strangulated, pixelated. Then our imaging got better. 1996, we got a gray fuzzy ball. 2002, we got colored. And of course, 2018, we got the color high saturations. And our famous picture here was taken on July 2015 by the New Horizon probe. And here's a little known fact that people are not aware of. Some ashes from Tom Clybau's remains were on board the New Horizons probe as it passed by Pluto. So Tom Clybau got a chance to visit Pluto after all. I always thought that was cool and special. I mean, Pluto, our view has totally dramatically changed. With our observations getting better and better, we're discovering more and more in our own solar system as well as beyond. Which leads us to our number one. Before I go on this is a black and white view of Pluto's horizon. Yes, this is the atmosphere of Pluto, as taken as New Horizons was passing by. And my favorite shot ever is the actual atmosphere itself against the blackness of the Pluto. Pluto has a thin atmosphere of nitrous oxide, mainly nitrogen oxide. Think another place. Mainly nitrogen. But I love this picture of Pluto. This is on my phone. This is my lock screen, by the way. Hashtag lock screen. As New Horizons departed Pluto, it took one last shot. This is the last shot that it took, and I love this picture. So let's get down to number one. What is the number one wonder of our own solar system? What could it be, possibly? Who could it be? What could it be? Nope. Our number one solar system is Earth. Yes, Earth. Come on. Our number one solar system, number one wonder of our solar system is Earth. It's unique. It has life everywhere. It's the only place in our galaxy that we know of, only place in our solar system that we know of that has life on it. I mean, we have different seasons, different changes. We've evolved. I mean, at the beginning, we only thought that our solar system was unique, and we thought that Earth was the center of everything, until scientists found out that Earth is not the center, but we orbit around the sun. And as we expand our own knowledge of the universe, we find more and more wonders. Just as this picture was taken from the Earthrise by the Japanese lunar orbiter spacecraft Kaguya, Kaguya. You may remember the famous Earthrise. This is the newest Earthrise to the high-def video. Yes, we are a very small, little, tiny planet. We are special in this solar system because we're the only planet that has life on it. This is why I call Earth the number one wonder of our solar system. Nowhere else have we found yet, and I did say yet, that there is life anywhere. And I want to thank everybody here for joining me today on another episode of What's Up with the Universe. What did you have to say that? Wait, I heard Uranus had life space worms. Maybe in a science fiction book, LDG. And no, DG, you're not the center of everything because you are not fat. That means gravity does not orbit around you. You are skinny, dude. You're not fat. And I want to thank everybody here for joining me. And don't forget to click that like, subscribe button, and to ring that bell so you know when I go live. The only black hole, Deej, is my love for chocolate. Gotta have more of it. Okay, well, I want everybody to take it easy, and thank you for joining me here. And until next time, we get a chance to talk about what's up with the universe. So, hey, who knows what I'm going to talk about? Make sure you ring that little bell here.